who are present here. Our resource person is online. Our today's
mostly time is there, na?
Yes. So okay, sir, we are waiting. 1 2 minutes. Yes, sir.
Okay.
Yes, sir. Okay, sure. So, hello and a very good evening to everyone who are present here. Our today's distinguished speaker is Professor Kalyan Chatterjee. Thank you, sir, for joining us and giving your valuable time in this FDP. We are honored to have your presence here. Now, I'm going to introduce about sir. Dr. Kalyan Chatterjee is a professor in the Electrical Engineering Department, IIT ISM Dhanbad, where he is a faculty member since 2005. He is currently holding the position of head of the department. Professor Chatterjee completed his PhD from BIT Mission Ranchi and postgraduate from Jadavpur University. He has guided 13 PhD scholars and 5 are ongoing. He has also published 86 international papers in different reputed journals. Professor Chatterjee also holds different administrative posts in IIT ISM Dhanbad, like Associate Dean R&D, Chairman of JRF Admission Committee, etc. He also successfully completed 3 external funded projects. His research interests are soft computing techniques, renewable energy, power system stability, etc. So, hand it over to you, sir. Thank you, sir.
Thank you, Dr. Dile. Today I just start the artificial intelligence techniques. Actually, the hybrid artificial intelligence techniques. In the we not go through the application parts. We actually just starting the what is the hybrid intelligence system and how we actually construct the hybrid intelligence system in our real time application. Okay, so this thing is actually visible to everybody.
Yes, sir. Yes, sir.
Visible, sir. Okay.
Yes, sir.
So we actually the today topic is actually mainly consider the hybrid intelligence system. Here we go through the neural expert system and the neuro-fuzzy system. So before we start that, so today actually we go through the what is the introduction part, neural expert system, neuro-fuzzy system. We go through the ANFIS, adaptive neuro-fuzzy inference system, and later we actually consider the overall summary of the lectures. Now, what is the intelligence system? First thing is actually when you can go through the intelligence system, what is the basic structure of the intelligent system? Why when one system is actually called the intelligence? Any intelligence system, the main objective is that they perform a meaningful operation. Meaningful operation means when you can give this an input and you also got a output, you actually interrupt that input and output of the system. I mean, there is actually correlation between the input and output of the system. So the first term you actually go through the when your system is intelligent, we always say that they will perform a meaningful operation. Second is the interrupted information, means that you have the idea. When you can consider the intelligence system, you can analyze that output. Mean that you have that much knowledge in your system, or you should actually, you can interrupt that information. What is the, if you got the large number of information in your hand, so you can actually find out the what is the input and output relationship, comprehend the relationship between the phenomena or objective, apply the accurate information of the new condition. Means the, if the system is actually go to the any new conditions, that system should be adapt for the new environment. So when this type of the property is available in the any type of the system, then you say that the system is intelligent in the natures. Now, what is the short-term objective of any intelligence system? So everyday routine tasks. You understood this thing. Every day we actually some routine tasks of the human beings. So the vision, language processing, common sense reasonings, and the learning. So these type of the, when you can consider, that is the intelligence in the natures. You understand the vision, language processing, common sense. This is the everyday work in your system. But when you can consider artificial routine tasks, identified and developed by the human beings, then this is not common in the natures. Artificially you can actually develop some of the games, mathematics, logic programming. That is the artificial routine task identified and developed by the human beings. So this is also the intelligent, we actually consider intelligent in the natures. So when we actually find out the games, mathematics, logic in the programming. Now expert tasks developed by the human beings, that is doctor, physics, mechanical engineering, accounts, and other specialization. So any specialization of the work when you actually done, that is actually you can consider expert task developed by the human beings. So you can understand this, this is the short-term objective of the intelligence system. Three terms we actually discuss: everybody, everyday routine tasks, artificial tasks, and the expert tasks developed by the human beings. Now, what is the long term of the objective in a system? Or long term objective is the develop the system which can enhance to replace for the human beings of the difficult situation. Means the what is actually develop. Long term objective is the when we design any system, you can incorporate the human knowledge for the particular system. The long means that you can suppose one mobile phone, such type of the phenomena when the long term objective of the intelligence system, that can be actually we can develop, can enhance the replace for the human beings in a difficult situation, can be physically march with the human being to replace failed body parts. So this is the long term objective of the intelligent system. Now, what is the traditional approach? How actually you can develop the intelligence system? Means the artificially how actually develop the intelligent system. Either you can actually go through the mathematical models. So mathematical model is this is actually the incorporate your own knowledge, human knowledge into the system. So either you can go through the back blocks or number crunching or rule based system. That is the keeps or by valid. Mean the large rule based system you can form that depending of your experiment, you can actually produce the some rule based in your system and then you can design the system. So two different type of the approaches there. Either you can go to the mathematical model or either you can use the rule based system. Now the subcomputing main objective is that mimic the human reasoning, that is the linguistic reasoning in our cases. But the main constant when you can consider the any subcomputing in the natures, when you can use the every time we actually consider the what subcomputing part in our cases. So the four different constants we actually mainly occur in our system. One is actually we can go to the fuzzy system, neural network, evolution computing, and probabilistic reasoning. Another is actually you can go through the when you can either evolution computing, you can also go through the optimization technique. So this is the four main constants we actually derive from the our artificial subcomponent technique, or you can actually we can use the intelligent system. So the what is the definition of the subcomponent? Before we start the intelligence system, we every time we actually consider that this is the one part of the subcomponent. Now, what is the soft computing? What is actually the main emphasis of the soft computing techniques? Now, the soft computing is an emerging approach to computing which parallel the remarkable ability of the human mind to reason and learn in an environment of uncertainty and imprecision. You understand the words. Soft computing is an emerging approach to computing which parallel the remarkable parallel processing. Actually, parallel processing means here we actually consider the large number of signals is coming at a time. Ability of the human mind mean the large number parallelly we actually consider the large number of signal human mind to reason and learn. This is the main advantage of the our soft computing. We can learning depending on our environment, learn in an environment of uncertainty and imprecision, because you understand this thing when you can consider the mathematical logic or you can consider the hardcore mathematics. So every time there is some mathematics behind it, but all the in our real life, or you can consider the when any design any system, lot of uncertainty is there. So when the uncertainty and imprecision is occur in any system, their soft computing is actually play a major role. Now, what is the difference between the hard computing versus soft computing? Hard computing means what is actually the conventional computing techniques is available in the suppose the linear algebra differential equation. That is actually you can call soft computing, hard computing. And what is the main difference between the hard computing versus soft computing? Hard computing is actually the real-time constants. When you can actually use the any real-time constant in your system, so there we actually consider the hard computing. Need of accuracy and precision in calculation and outcome. You understood this thing? When the accuracy and the precision is in your system, there we apply actually the hard computing system and useful in the critical system. This is the three property in when you can actually use the hard computing. Always we actually use the real-time constant. So you can understand this thing when we use the x, one parameter, one variable. So x is actually the we can got a particular value. We not consider this is the range of the x in your system. So we actually consider the real-time constant. We actually not say that this is the nearby x, this type of the word we actually consider. So x is 5 means you have the idea the x value of the x is equal to 5. So real-time constant is there. Always the need of accuracy means the when you can consider understood this thing, if we consider the y equal to s square and x is some value is there, we always got that's exact value. We suppose the x is equal to y equal to s square, x is equal to 2, so y is always the 4. This is not the near about the 4.1, 4.2. So there is the accuracy value is actually there. As well as the calculation mean that this is the accuracy of the precision and the calculation and the outcome. Third point is the useful in the critical system. When the exact result is required, when the robust as well as the you can consider the accuracy is required, so there we use the hard computing. Now, what is actually the soft computing? Why do we use the soft computing, and what is the main feature of the soft computing? This is the soft constant. Soft constant means this is not accurate value. We actually not consider. We actually consider the near about, large. This type of the words we use for the soft computing techniques. Need of robustness rather than the accuracy. You understand this thing? Here we not go through the accuracy is there. Here we actually consider the robustness. Mean that if the any uncertainty, imprecision, if any type of the disturbances occur in your system, we actually got the results. So rather the accuracy in the subcomponent technique, we actually require the robustness of the system and useful for the routine tasks that are not critical. So when the critical system will not use the subcomponent, but if the system is any routine tasks, you can actually handling. Suppose every time the same numerical analysis is actually you can done. So there we use the subcomputing technique. We actually the replace the your hard computing to the subcomputing when the accuracy is not at all or required. We have required the robustness of the system. Another is we can use the subcomputing is different from the conventional, mean the hard computing. In that is drawn on the following: when the imprecision is there, uncertainty, partial truth, and the approximation. When these three is present in your system, there the hard computing is the fail. So there we actually use the subcomputing: imprecision, uncertainty, partial truth, and the approximation. In effect, the role model of the subcomputing is the human mind. You understand this thing? We always we not go through the exact what. So what is actually the instant you can actually do? So you can actually do this type of the system. So when the uncertainty imprecision is there, so there we actually use your own logic. So that part of the we actually the effect of the role model of the subcomputing is the human mind. The guiding principle of the subcomputing is that exploit the tolerance for imprecision, uncertainty, partial truth, approximation to achieve tactfully and the robustness and the low solution cost. Low solution cost means actually you understand most probably the everybody. So this is actually we use our algorithm part of the system, and the very easily this is not so the time consuming, so you can use your own rule base in your system. So very quickly you can solve your any system depending of the problem to problem. Your solution cost is also changed. But the you understood this thing when we actually use the subcomputing this type of the term. So four parameter, four different thing we actually mainly handle: imprecision, uncertainty, partial truth, and the approximation. So the main difference we discuss about the what is the difference between the hard computing and the subcomputing. The subcomputing techniques where we apply when the when the uncertainty, imprecision, and the partial truth is present in your system. Now, what are the advantage of the subcomputing? You understood this thing. What are the advantages of the subcomputing? First advantage is that this is the model based on the human reasoning. Means that you can design your own model. This is not depend on the mathematical model is there. So depending of your own knowledge base, you can actually design your model. So model is based on human reasoning. So you can create your own model closer to the human thinking. So what is actually you think your system, your previous knowledge from the system, you can actually modeling the overall system. Models can be linguistic. Linguistic means actually the what we actually consider the what term linguistic, what we actually use the fuzzy system. So later we actually consider what is the linguistic term. That is the very big, very small. That type is not in the hard computing techniques, but subcomputing techniques. We can actually use this type of the word: nearby, very small. Because what is actually the everyday lives, which type of the word we actually use. This is a nearby. This type of the word we use. You can understand this thing when you can actually consider the distance. We not say that every time this is the 5 kilometer away from this. We actually consider the 5 kilometer. We actually consider near about the 5 kilometer. So this type of the near away. So this type of the word when we can use. So this is actually you can consider the linguistic term. Simple, non-number crunching, comprehensive, no black boxes, fast when in computing, and the effective in the practice. So advantage of the your subcomputing technique is actually the model is based on the human reasoning. Neither this is actually the we can consider the mathematical problem is there, and this is actually closer to the human thinking. And model can be linguistic, simple, fast when computing, effective in the practice. What is actually possible subcomputing data and the operation? So this is actually you can numeric data. You can understand about 5 to 6, about 5 to. So you can see that there is no exact data we actually consider here. This is actually you can we consider the linguistic data. When you can consider numeric data, we also use when you can consider about 5 to 6, about 5 to 6. Linguistic data when you can consider that this is the cheap, very big, not high, medium or bad. Function or relationship we consider the about fx, fairly similar, much greater. So this type of the operation we actually use for our subcomputing techniques. Now the construction of the fuzzy system, you can see that the four subcomputing techniques we already mentioned. Now, why do we use which type of the technique? So when the imprecision is there, so we actually use the fuzzy system. You understand fuzzy system. Later we actually discuss neural network when the learning is required. When the neural network is actually, if the neural network is actually learning algorithm, we actually have a neural network. Probabilistic reasoning with the uncertainty is in your system. So there we use the probabilistic reasoning. Another when you can use the optimization, we can use the evaluation computing. So when the imprecision data is in your present, you have the knowledge in your system. Then we use the fuzzy system. When the learning is required in your system, so there we use the neural network. When we use the uncertainty is there, so there we use the probabilistic reasoning. And the evolution component, when the optimization we use, you understand this thing, when the optimization is required, so there we use the evolution user. Now we actually consider, before starting from the hybrid approach, we actually discuss about the two parts. One is actually just 2 and 3 side. We actually consider what is actually the fuzzy and what is actually neural network, because we use the hybrid approach. Before this term is you very much required. So what is actually the fuzzy concept and what is actually the neural network concept? Concept of the fuzzy description, use of the linguistic variable rather than the quantitative terms. Again, I repeat, fuzzy system we not consider the exact term. So there you use the linguistic term. Linguistic term means you can understand this thing. Better you can the consider the fuzzy number. You can consider the when you can consider the quantity 0. So this is, you can see that we can represent by the any system is 0 in a system. When you can consider almost 0, in the fuzzy system we actually represent in this way. You understand this thing, when the two type of the why it is called the fuzzy number. First we understand this thing, what is the actually difference between the Gibbs number and the fuzzy number. Gibbs number is the two value, either this is 0 and the 1. Means you understood this thing. If we consider the 5, means the 5, there is nothing, another value is there. And when you consider keys value, either yes or no. This is the two parameter is there. But when you can consider the fuzzy number, between the 1 and 0, we actually go through the membership functions. So that is actually represented by the fuzzy concept. So you can understand this thing. When you can consider the keys value, 0 means actually 0, almost 0. This is we can actually represent in this way. And this part, x-axis actually we can consider the your keys value, and the y-axis actually you can represent by the membership value. Membership value is actually represented by the 0 to 1. Between the 0 and 1, we actually represent the your Gibbs number. Gibbs number, or you can consider the universe of discourse, that is actually represented by the your y-axis. And the near 0, we actually also consider, you can understand this thing, we can represent into the in this way. So the fuzzy system and the you can answer the your our conventional keys value, the representation is the totally different. So this type of the representation you actually represent by the linguistic variable. We can also consider the membership representation in a system. So you understand this thing, use a linguistic variable rather than a quantitative. Linguistic variable means this term, almost 0, near 0. This type of the words we actually use, instead of we actually use the quantitative variable. The linguistic variable has the value expressed in words, representing the qualitative concept of the implicit about the state of the system. The idea to capture vague, implicit, fuzzy variable description, that is the large, medium, big, not very large, etc. This type of the word we use the fuzzy system. To convert the linguistic term into the numerical value, one needs to fundamental of the set theory. So there, fuzzy set theory is there. I not go to the details about this thing. This is the another chapter of fuzzy system. But we use the just like the set. What is the fuzzy set? Within that, we actually represent by the all the linguistic variable. The Gibbs set theory is the element is that neither number membership get is 1 or 0. But in the fuzzy set, we between the 1 and 0, we actually represent by the membership function. So we understood this thing. When we can use the fuzzy number, we can actually use the fuzzy number between the 0 and 1. We actually represent the system into the in this. So this is just like a use the. This is called the tangular membership function, tangular linguistic variable. We actually use in this way. Now understood this thing, how the why the fuzzy system and how actually represent, because you understood this thing. If we consider the suppose the 70 after the 70 kilometer, you can, if we say that this is the overspeed. Now if we represent by the Gibbs concept, you understand this thing, up to the 69 your speed is very low, consider the low speed. But when this system is reaches to the 70, suddenly it is jumped to the high speed. Means that you can understand this thing, what is the you can consider your exact value. Depending on that, we actually consider the 0 and 1. Again, I repeat, you understood this thing. Suppose your 70 kilometer is the high speed. Up to the 69.9 or 69.99, your speed is very low. Just the system is reaches to the 70 kilometer. So this system is actually given the overspeed in a system. But the fuzzy system is not represented in this way. fuzzy system is actually given the membership value. So you can see that the how actually can represent. You can see that the 50 after the 60 to 65 speed set of the speed is just given to the triangular membership function. And if the 69.9, this is given the your overspeed is the 0.8. So this type of the weightage is actually put into the fuzzy system. Instead of we actually put the 0 to 1, between the 0 to 1, if any value we can represent by any membership value, we actually represent the fuzzy set. So then we actually consider the we actually represent by the fuzzy system. So this is the you can see that the two axes is there, x axis and the y axis. X-axis is represented by the real value, that is called the universe of discourse. The x-axis is just 50, 70, 100, that is actually the real value, that is called the universe of discourse. And the y-axis is actually given the membership get, that is you can represent by the mu. So this thing is clear, everybody? What is the fuzzy membership function? Hello? Hello?
Yes, sir. Audible, sir. Clear, sir.
Next, we actually consider the what is the
Yes, sir.
difference type of the fuzzy logic based system is there. When you actually consider the fuzzy logic based system, what is the four different parts? Mean the how actually design a fuzzy logic based system. Four different part is there. One is actually the when you can consider the any subcomputing system, you have the data, sufficient data is input and output data is there. So you understand this thing. The basic configuration of fuzzy logic system is the fuzzification, knowledge base, decision making, and the defuzzification. So this is the four part is there. So any type of the system when you can design in the fuzzy system, there is a four part is there. Mean the real part, real time system in real data. First is fuzzification. Means the real time data we actually depend on the membership function. Then what is the previous knowledge of the your system? Depending on that system, we actually find out the inference engine. So you can see that this diagram. So first the any input is there. So after the can fuzzify, then the your knowledge of the particular system, we actually go to the inference engines. Then we actually go through the rule base, that is the your decision making. And after that, again we actually convert to the your fuzzified value, membership value in the real value. That is actually called the defuzzification. So this is the four difference part in the your fuzzy system is there: fuzzification, knowledge base, and the decision making. Sometimes the knowledge base and the decision making we actually both we actually consider at one at a time. That is called the inference system and the defuzzification. This is the four main part in the your fuzzy system. So these four part, when you can consider hybrid system in the these four part we mainly apply into the neural network system. So now next part is actually the what is the basic concept of the neural networks. I just one, two, three, say like you can understand this thing. What is the fuzzy system and the neural network? Because we actually consider the hybrid system. In the neural network, you can see that. Mean that we can go to the architecture point of the view. You can see the large number of signal is coming from the your biological neurons. That is actually the go through the your nucleus. That is actually put the signal analysis in a system. That signal is actually go through the your oxygen, and then is actually the different other dendrites is connected in your system, and then you go to the output. So that biological neuron we actually represent by the artificial neuron in this way. The large number of input, that is the parallel, large number of input is coming in your processing unit. The processing unit is there. So after this processing unit, that is go to the output. Now the artificially we actually how actually can represent the overall artificial neural network. So you can see that the input is there. Neuron here we actually the what is the logic we actually use, that is the processing unit. And between the which input we actually process and how we actually give the your mean the weightage in your system. So that point of the view between the input and the your processing, we actually put the different of the weight matrix. So the here the and the then output is there. So when we actually consider the ANN, our learning of the system, we mainly learning the weight matrix. We actually upgrade our weight matrix, and that we actually learn the your system. So learning the neural network, the main feature of the neural network is actually the learning in the nature, learning in the system, because in the fuzzy system in the imprecision. And when you can consider the ANN, the main feature is actually the weight matrix. So the input is not in your hand. Again, I repeat, the input is the large number input is coming in your system. Output is already fixed. So in your hand only the weight matrix. So when you can consider the ANN, mainly the learning algorithm, any type of the learning algorithm when you can actually design, that is we actually upgrade our weight matrix. The basic structure of the neural network is that the neural only fires if its input signal exceeds a certain amount, that is threshold the short time period. Means this threshold value is also actually fixed by our weight matrix. Means that depending on the your, after that you can understand this thing, input into weight matrix, that is actually value is actually go to the your processing unit. This if the value is actually more than the your threshold value, so this system is actually go to the output, otherwise the system will be terminated. So everything is actually depend on the your weight matrix. So synapse strength vary in strength. Good connection allow the large signal, slight connection allow only the weak signal. So mainly when you can consider the neural network, the main parameter is actually the choosing the your weight matrix, and that we actually learn that throughout the your system. So the two thing we actually understood this thing when you can consider the fuzzy system. So there is the fourth part is there: fuzzification, knowledge base, decision making, and as a refuzzification. And when you can consider the neural network, the main feature is there the learning in the natures. So now how these two important subcomponent, how we amalgamate these two parts, mean how we actually the hybrid approach we go through the neural and the fuzzy system. Now, what is the hybrid system? First, we actually go through the what I understood this thing. What is the hybrid system? The real life problems may neither fit the assumption of a single artificial intelligence techniques, not be effectively solved by the strength and the capability of the single techniques. One approach to deal with this complex real world problem is to integrate the use of two or more techniques in order to combine the different strength and overcome each other weakness to generate the hybrid solution. Means what you understood this thing, again I repeat, in the two network, what we actually discuss here, neural network and fuzzy logic, every system there is some advantage and the disadvantage. So this disadvantage can be overcome by the another system to make the system is more intelligent. So that point we use the hybrid system. So you understood this thing, every system there is some advantage and disadvantage. So advantage of the any system or disadvantage of the any system can be overcome by the advantage of the other system. So you understood this thing. When you can consider the neural network, the advantage of the neural network is no mathematical process model is needed, no rule-based knowledge is required, different learning algorithm is available. So mainly the neural network, the main feature of the advantage of the neural network is actually the different learning algorithm. So you understood this thing. If different of the learning algorithms available in the neural network system, they will be easily, any atmosphere they easily actually learn. But the fuzzy logic system, when you can consider advantage is that no mathematical process model is needed, because there is no mathematical process both system. Prior knowledge can be required. Previous knowledge is required for the only the rule based in your system, because this is the what is the input output relationship. So what is the previous, depending on your previous knowledge, you actually design your fuzzy system. And simple interruption and the implementation. The main feature of the fuzzy logic system is you can incorporate, you understood this thing, in the neural networks, you can only design the input and output. You cannot improve the system. You can not emphasize the input of the system, because only you can learn only the system. But in the fuzzy logic system, you can incorporate your own logic to the system. The main advantage of the neural network is actually the different learning algorithm, and the fuzzy logic system is that you can incorporate your knowledge to your system. Now again, I consider the disadvantage. What is the neural network? This is the total black box. Rule cannot be extract. Prior knowledge cannot be used. No guaranteed the learning converts. Determine the historic parameter. And fuzzy logic, you can say rule must be available. Rule must be available means you can use the old logic. So rule must be available. You have required sufficient knowledge in your system. The system cannot learn and update. Adoption to modify the environment is difficult. Tuning may not be successful. No formal method for training. You understood this thing. This is the disadvantage of the neural network is actually the no rule base in your system, as well as the prior knowledge cannot be used. So you have the sufficient knowledge in your system. You can input the system, but in the neural network you cannot incorporate that knowledge into the system. But when you design the neural network, you not incorporate the system. But when you can use the fuzzy logic, so you understand that the previous knowledge you should be used in the system. So rule based, you can understand this thing. The rule is available, so you can design your own rule. But the disadvantage is that learning is not possible. So what is the disadvantage of fuzzy system that can be overcome by design the neuro fuzzy over system. So that is our main approach today. I just discuss about how we actually design the neuro fuzzy intelligent system. Mean the how actually we can design that our hybrid system. So first we actually consider the how the neural network is expert. Mean the how the neural network we actually design the neural expert system. So what is the basic feature and how we actually design the neural expert system? So you understood this thing. Neural expert system is expert system realm of the logical inference and decision trees and focus on the modeling human reasoning. So you understood this thing. Again, I go through the step by step. What is the expert system and how this expert is we actually incorporate into our neural network. Expert system really on the logical inference and decision trees and focus on modeling of the human reasoning. Mean that when you can consider the expert system, here we actually use your own logic. Mean the logical inference is required. Decision tree means that you can put your own decision. Means that you can improve and focus on modeling of the human reasoning. So neural network really in the parallel data processing and focus on modeling of the human being. So when we actually consider neural expert system, so we actually focus on modeling of the how the neural network architecture, how we actually use our how the neural network we actually modeling. So that is actually the near about the human brain or human logic will be incorporated in your system. So then we actually consider the this is the neural expert system. But in the neural networks, we use our own logic instead of that. This is learning input output relationship. You can use your own logic into the neural network architecture. Then you can consider that this is the neural expert system. Expert system treat the brain as a back blocks. Obviously, neural network look at a structure and function particular at is arbitrary to learning. So learning capability in the neural network is there. So that we actually also use the neural expert system. Knowledge in a rule-based expert system is presented by if then products and road. So that is also used into our neural expert system. Knowledge in the neural network is stored in the weights, because you understand this thing. What again every time I emphasize the weight. What is the previously we actually consider the weight matrix. Now this weight matrix we choose in this way, that is actually give the our input output relationship. What is actually the fuzzy system? We actually consider the input output relationship in your system. The same knowledge we actually incorporate into our neural network architecture. Means the knowledge of the neural network is stored in the synaptic weights between the So what is the weight that way to choose in this way? That is actually give our input and the output relationship. In the expert system, knowledge can be divided into the individual rules, and the user can see and understand the piece of knowledge applied by the system. Knowledge can be divided into the individual rules, and the user can see and understand the piece of knowledge applied by the system. In the express, a large number of rules is there, but every rules we actually interact. In the neural networks, one cannot be select a single weight a discrete piece of knowledge. Here the knowledge is embedded in the entire network. You can understand this thing. We use not a single weight at a time, because all the weight is interconnected to each other in the expert system. So knowledge can be divided into the individual rule, but the neural network is one cannot select a single weight at a discrete piece of knowledge. Here knowledge is embedded in the entire network. It cannot be broken into the individual piece, and any change in the weights may lead to the unpredicted results. A neural network is in fact the black box for the user. So that is the we actually consider the learning apply. here the expert system is the knowledge we can divide individual, but when you can consider the neural networks, the learning algorithm, by using the learning algorithm, we actually change the weight and overall the input output relationship we actually design. Okay, we combine the advantage of the expert system and the neural network to create a more powerful and effective expert system. So when we actually design the expert system, that we actually consider the neural network. So both logic we actually incorporate to each other, and then we actually go through the neural expert system. So the hybrid system that combines a neural network and a rule-based expert system is called the neural expert system. Again, I repeat, a hybrid system that means that in the neural network architecture, we use the rule-based expert system, and then we actually go through the neural expert system. So now, what is the basic structure of the neural expert system? You can see that we already go through the neural network architecture. You can see that the input data is there. After that, the weight matrix, and then we actually not discuss about the hidden, but you can understand this thing. Any neural network, there is the three part is the input layer, output layer, and between the input output hidden layer is there. In the hidden layer, we actually mainly use for the different of the weight matrix, and that is should learn. But here you understood this thing when you can consider the neural expert system, that hidden layers we actually use our inference engine. What is the knowledge? You understand this thing. In the fuzzy system, we actually consider the fourth part: fuzzification, defuzzification. Between the fuzzification and defuzzification, the knowledge base and the inference engine is there. Similarly, here the knowledge base, you can use the when neural network is if we go to the knowledge based system, we use the inference. Sorry. We use the inference system here. So you understand this thing? We use the inference system here. So here the new data we actually put. This is visible, everybody? Hello?
Yes, sir.
Yes, sir.
This is, you can see that the every neural network, the two thing is required: large number of data set. You understand? You know this thing. Every neural network is required. So if you consider your supervised learning, so that your input and output data set is there, and between the input output, so you can learn the network. So same structure we actually use for your neural network system when you can consider the expert system also. So that you can use the new data, means before you can use the data set, and in the hidden layer, instead of we use the different weight matrix, so this way to choose in this way, so you can use the human logic. Mean what is the fuzzy system, what is actually considered the if then rule, that inference engine is actually you can use for your weight generation. So you can see that this fourth part is that new data, neural knowledge base, and the rule extraction. So when the rule extraction, you can see that the user interface, this is actually the knowledge of the user, and depending of your knowledge, previous knowledge of the system, you can actually create your inference engine, and that due to that inference engine, you can actually create your own weight matrix, and that weight matrix actually can put from the input and output layer, and after the learning your weight matrix, we actually got our expert system. So this is the basic structure of our neural expert system, neural knowledge base, rule extraction, and the inference engine. You can understand this thing when we can consider neural network is okay, but when you can consider our neural expert system, the heart of the neural expert system is actually the inference engine. You understand hold the data, you can understand this thing. This is when you can consider the system is expert, so this is the main heart of the system, mean that you can use your own logic into the neural network architecture. Because if a conventional neural network, you can only train the network. You cannot change your input and output pattern. So what is the value is actually available, that you actually only predicted. So that within that range, but if you want to input your output, so there we use the neural expert system. That is we can use the inference engine. So the heart of the neural expert system is the inference engine. The inference engine control the information flow in the system and initiated the inference over the neural knowledge base. And the neural inference engine also ensured that approximate reasoning. So mainly the heart of the neural expert system is the inference engines. The inference engine is control the information flow to the system and initiated the inference over the neural knowledge base. A neural inference engine also ensured the approximate reasoning. Now, what is the approximate reasoning? First, you understood this thing. In a rule-based expert system, the inference engine compares the conditional part of the each rule with data given in the database. So the rule-based expert system is the inference engine compare the conditional part of the each rule with the data is given to the database. That means the if-then rule. So if this is in your system, this is the input, that is the output. So what is actually the fuzzy system? What is actually considered the rule base we actually design? The same rule base we actually design into our neural network architecture. When the if part of the rule matches, the data can be data in the database, the rule is fired, and then part is executed. So later we actually consider architecture means the every node of the neural network we actually fuzzify. And when the real input is coming in your system, so if the real input is within the range, then the system is fired, and then the next step is actually the execute. So precise matching is required. Information engine cannot be copied with the noisy and incomplete data. So proper data set is required. So this thing is actually obviously in our neural network also. One. Sorry. Hello. अब ये कर रहे हैं लेक्चर दे रहे बाद में neural expert system use a 10 neural network in place of the knowledge base. The input data does not have a precisely match the data that was used in the network training. This ability is called approximate reasoning. Okay, the neural expert system use a 10 neural network in place of the knowledge base. The input data does not have a precisely match the data that was used in the network training. This ability is called the approximate reasoning. The neural expert system used in the 10 neural network in place of the knowledge base. You can understood this thing. In the previous, when you can neural network, we use our conventional data set, but in the neural expert system, use the 10 neural in place of the knowledge base. The input data does not have precisely match of the data that was used to the network training. This ability is called the approximate reasoning. Now, neurons of the network are connected by links. I just go through the architecture, then you better understood this thing. I just go through what is the architecture, then you understood this thing, what is the different type of the neurons in the network are connected by links, each of which is the numerical weight attached to it. The weight is the 10 neural network determine the strength or importance of the associate neuron inputs. So you can see that, just I go through the architecture, then you better understood this thing. When we can consider the neural expert system, or you can see that what is the architecture. So you can know our conventional neural network. So layer 1 is there, means the input layer, output layer. Between the input and output layer, we use our hidden layer. So here when you can consider the neural expert system or neural system, there is the 3 part is there. So layer 2, that is the after your input layer, what is the after the input layer, that layer 2 is actually the fuzzification layer, then the rule based layer, then the defuzzification. Just like our fuzzy system, you understood this thing. There is a 4 part is there, fuzzification. Then you can consider your knowledge base, that is the inference system, that is your knowledge base. Then the defuzzification, the same architecture we use to our neural expert system. So next when you can consider neural expert system, first we actually go through the neuro-fuzzy systems. So you can see that the neuro-fuzzy system, fuzzy logic and neural networks are natural complete tool in building the intelligence system. The fuzzy logic and neural network are natural complete tool in the building the intelligence system. Here we actually consider in the neural network architecture we use when you can consider neuro-fuzzy system, the neural network architecture we use the fuzzy concept. Okay, so the first structure is actually the fuzzy logic and neural network are natural comparative tool to building the intelligence system. While neural network are the low-level computational structure that perform well when dealing with the raw data, and fuzzy logics deal with the reasoning on a higher level using the linguistic information acquired from the domain expert. So you understood this thing. Neural network, we actually consider the computational structure, means the input and output, then we actually learn the network. You cannot use your own logic. You can only use the different of the learning algorithm. Depending on your learning algorithm, you can actually consider the input and the output in the system. But the fuzzy logic, we actually dealing on the reasoning of the higher level, means that you can use your own logic in your system. How the fuzzy system lack of ability to learn and cannot adjust themselves to the new environment. That is the main disadvantage that can be overcome with your neural network architecture. On the other hand, neural network can learn, but they are not into the you understood this thing, opaque to the user. So other hand, although the neural network can learn, they opaque to the user. So this is actually the learn, but the user can not incorporate their own knowledge into your system. So when you can consider the fuzzy neuro fuzzy system, that should overcome. So we use the fuzzy learn the system, as well as you can incorporate your own reasoning to your system. So synergy of the neural and the fuzzy indicated the neurofuzzy system can combine the parallel computation and learning ability of the neural network with the human-like knowledge representation and explain the ability of the fuzzy system. As a result, the neural network become more transparent, while fuzzy system became capable of learning. So you can understand this thing. When you use the neurofuzzy system, so neural network become more transparent, because you can understand this thing. Neural network, we actually design your own way, and this is the most transparent, and fuzzy system becomes capable of the learning. So the learning capability we also incorporate into our system. So neurofuzzy system is a neural network which is functioning equivalent to the fuzzy inference model. What is the structure, what the basic structure, what are the basic feature of the neurofuzzy system? A neurofuzzy system is a neural network which is functionally equivalent to a fuzzy inference modeling. Neurofuzzy system can be trained to develop if-then fuzzy rules and determine the membership function for input and output variables of the system. So neurofuzzy system can be trained to develop if-then fuzzy rules and determine the membership function for input and the output variables of the system. Expert knowledge can be incorporated into the structure of the neurofuzzy system. At the same time, the consistent structure about the fuzzy inference, which entirely substitute computational burden. So mainly the neurofuzzy system, when you can actually use the neurofuzzy system, mainly with the neural network architecture, we use the fuzzy concept. The structure of the neurofuzzy system is similar to the multi-layer neural network that we have already, what is actually you can show the network. The structure of the neurofuzzy system is similar to the multi-layer neural network. Multi-layer neural network means you already know the input layer, output layer, and the hidden layers. The same architecture we use the neurofuzzy system. In general, neurofuzzy system has the input and the output layers and 3 hidden layers that represent the membership function and the fuzzy rules. You understood this thing? In the neurofuzzy system, the input and output layer, depending on the number of inputs, we actually consider the input layers, and what is your output, that is also we can actually consider the output layers. Between the input output, 3 hidden layer is there. These 3 hidden layers is actually represent the fuzzification, knowledge base, and the defuzzification.
Sir, as per ATAL schedule, we have to give 10-minute break to.
Okay.
Yes, sir. Yes, sir. We may start by 8, sir.
Okay.
Yes, sir. So 10-minute break, and session will be started by 8. Okay. Thank you. Sir, we may start the session.
Okay.
Yes, yes.
Now this visual, na? Hello?
Yes, sir. Visible, sir.
Okay.
You may able to see.
Now, we actually go through the first neurophagy system. In the neurophagy system, we there is a three part we actually mainly consider: the input-output layer and three. Now, the input and output layer is actually the fixed. We not change the input and output layers number of nodes in the system, because number of nodes in the input layer is actually depend on number of input, and output layer also number of output in your system, that is actually also determine the number of nodes in the output layer. Between these three hidden layers, mainly we actually repair. You know, when you can go through the neural network architecture, our overall system, you understood this thing. Overall system is depend on your fuzzification, knowledge base, and the defuzzification. So these three hidden layer in your hand. So why do you actually incorporate your own knowledge or your own idea into the system. So this is the structure of the neurophagy system. You can see that the layer 1 is there. Layer 1 we actually mainly consider the input layer, and layer 5 we actually consider the output layer. Between these three layer 2, layer 3 and layer 4, layer 2 where actually in the neural network we can say hidden layer, but here the layer 2 is actually the fuzzification layer, layer 3 is the rule base, and layer 4 is actually the defuzzification. Now one by one we actually discuss. First, we can consider the each layer, and the neurophagy system is associated with the particular step in the fuzzy inference process. You understood this thing? Here, the neural network architecture, we actually use the fuzzy concept. So the every layer there is actually the knowledge about the how the fuzzy inference concept we actually apply to the neural network architecture. The first layer 1 is the input layer. So each neuron in the layer transmitted external keep signal directly to the next layer. That is the yi is equal to xi. So layer 1 is the input layer. Each neuron in this layer is transmitted external keep signal directly to the next layer. That is the yi is equal to xi. Okay. So that is actually the nothing about this thing. This is the what is actually the conventional neural network. What is the input layer is there. So that is actually you can consider the same thing we actually considered on also here. Also the layer 1, that is the input layer. Layer 2 we mainly use, that is actually considered as a fuzzification layer. So the neurons in this layer represent the fuzzy sets used in the attendance of the fuzzy rule. Attendance in the fuzzy rules. The fuzzification neuron receives the keeps input and determines the degree and which the input belongs to the neuron fuzzy set. You understood this thing. Here the second layer, we nothing about the second layer, we the fuzzified the input layer. What is the input is coming in your system, that is actually fuzzified into the your layer 2. The fuzzification concept we actually use the layer 2. So how actually go to later we actually discuss in this system. You understood this thing. So the layer 1 after the x1 you understand the same input. That is actually considered the layer 2. Layer 2 means the what is actually the you understand this first when you can actually fuzzify the system, you know the inverse of discourse, what is the total range depending of the your input range. We actually consider the number of linguistic variables. So that linguistic variables we actually consider the input. You can consider 2 input is there. Each input we actually consider the 3 linguistic variables is there. So here the first input, the linguistic variables is considered the A1, A2, A3. The second input, the linguistic variables is B1 and B2 and B3. And within these 3 linguistic variable, we actually use the fuzzification our input system. So there layer 1, the same thing we actually write down. Layer 1 is the input. Each neuron in this layer transmit the external keep signal. You understood this thing. This x1 is the keep signal, real value, and that is actually directly actually go to the your layer 2. The keys value actually go to the layer 2. From the layer 2 to layer 3, you can see that the system will fuzzify. What is the understood is there. So the membership value is actually coming. You can see that the mu a1, mu a2, mu a3. Similarly, the mu b1, mu b2, and mu b3. So here you can see that the instead of you can when the input is actually coming to the any layer, what is actually the your system will be fired. Depending of that, we actually got the your membership function. So the layer 2 is the fuzzification layer. So neuron in this layer represent the fuzzy set used to the attendance of the fuzzy rules. A fuzzification neuron receive the keeps input and determine the degree of which of the input belongs to the neuron fuzzy set. So the here you understood this thing. This in layer 2, when we use the layer 2, so there is the different type of the activation function or different type of the linguistic variable we actually use. So in this particular cases, we actually consider the triangular type membership function. The activation function of the membership neuron is set to the function that specified of the neuron into the fuzzy set. You understood this thing? If we go through these 3 parts, total triangular membership function. In this type of the every nodes of the your layer 2, that is actually represented by the this is the triangular activation function. So how actually you can represent? you can see that the X is your input, and that is actually if the system is lie between the A and B. What is the A and B parameter? You can understand this thing. So this X is actually the inverse of discourse in your system. That is the X parameter in yours. And A value, you can see that what is your top value. You can understand this thing. This is the top. This value is actually A. A equal to 4, A 4.5. So you can understand this thing. So if the change of the A value, your top of your value is actually changes. The X-axis is your real value. Y-axis is your membership value. And the A and B value is actually represented by your triangular membership function. So you understood this thing. What is the A parameter? What is the B parameter? So you can see that the A parameter is actually represented by your maximum membership function, mean your vertex of the triangular, and this is actually represented by your what is the width. So that is if the B value is actually changes, so your width is also changes. So the membership function, the activation function, you understood this thing. The A1, A2, and A3 is actually we can use the triangular membership. So what is the actually X is coming? If the X is the within the range, within the inverse of discourse, you can got the corresponding membership function. But suppose the X is A1 rule is if the X1 is a lie on the A1, so you can also go. So at that time A2 and A3 is actually the mu A2 and mu A3 is equal to 0. If the X1 is lie on the A2, so A1 and A3 value is actually coming to the 0. So this way we actually in the layer 2 we actually use the triangular membership function in this way. So triangular membership function can be specified with the two parameter A, B as follows. So this is the mathematical formulation. So where we actually put the all the layer 2 we actually design into the in this way. So everybody understood this thing? What I said? Hello?
Yes, sir. Yes, sir. Audible, sir.
Yes, sir.
Now, this is where we can consider the layer 2, we actually go to the triangular activation function. Now, the next we actually consider the layer 3. So that is actually we can represent the fuzzy rule. Actually, in the 2 input is there. Each input there is the 3 linguistic variables. In the as per the fuzzy rule base, there is the 9 rule is actually we generate. But in these particular cases, we only generate onto the 6 rule base. So you can see that the 6 rule we actually represent here, depending of your input database. So the 6 rules we actually represent here. So how actually you can represent the rules? You can see that just like if the x1 is this, x2 is this, then the y1 is this. So that way we actually consider the mu1. You can see that the second layer 2 to layer 3, depending of your rule base, all the if then rules. If the x1 is this, y1, x2 is this, then your rule is r1. Suppose you can see the mu a1 and the mu b1, mu a1 and the mu b2. So in this way we actually generate the rule base. So total 9 rule we generate, but here we only represent into the 6. So maximum rule we generate into the depending of the relation between your input layer and output layer. In total 9 rule we can generate. So that rule base we actually generate into layer 3. So fuzzy rule layer. So here we actually use your own logic. Okay. So what is the input output relationship that we actually put here? This is not the arbitrary you can put. If your input and input to input, what is actually relationship? Depending of that relationship, we actually generate the rule base. So fuzzy, this is the layer 3 is actually considered the fuzzy rule layer. Each neuron in this layer corresponding to the single fuzzy rules. The fuzzy rule neuron receive the input from the fuzzification neurons that represent the fuzzy set of the rule attendants. For instance, the neuron R1, corresponding to the rule 1, and receive of the inputs from the neurons A1, 2, and B1. So what is actually that your networks is coming, the A1 and the B1, depending of that, we actually generate our rule base. So second, your third layer, we actually generate our layer 3, that is the rule base in the system. So layer 3 is the fuzzy rule layer. Each neuron in this layer corresponding to the single fuzzy rules. A fuzzy rules neuron receive input from the fuzzification neurons that represent the fuzzy sets in the rule attendants. For instance, neuron R1, which corresponding to the rule 1, receive input from the neurons A1 and B1. You can see that the R1, what is actually rule R1? That is actually the find out the membership value mu A1 and the mu B1. So the rule 3, what is the rule? If first rule is actually generated, that is the relation between the A1 and the B1. See, in this way, we actually generate the all the rules. In the neurophagy system, the interaction can be implemented by the product operator. So you understood this thing. What is the mu A1? What is actually how actually coming? What is the output of the layer 3? The output of the neuron I in the layer 3 is obtained as the product operator. Means what is the number of input is coming? Suppose the if the large number of input is actually coming, so there is a product of the x1i, x2, 3, x. So that is the mu A1 and the mu B1. That is the mu R1. So you understood this thing. So the output of this system, what is actually the mu R1? That is the actually we can use the product operator. That is the product of the mu A1 into mu B1. Mu R1 is equal to mu A1. This is the membership function of the system. Mu A1 into mu B1. Now after in this way we actually generate the mu R1, mu R2 up to the mu R6. Here all the rule. Mean that layer 2 to layer 3 we actually use our own membership function, and layer 3 the output of the layer 3 we actually got for the product of the two membership function, which rule is actually fair. The output membership function layer. Now the next we actually consider layer 4. So that is actually we use our own logic, mean the fuzzy set theory. Sometimes we can consider defuzzification. Here the layer 5 is actually you can use the defuzzification, and this is actually you can consider the output membership function layer. So this is the one step we actually put here. So the output membership layer neuron in this layer represent the fuzzy sets used in the consequent fuzzy rules. You understood this thing that now we actually find out what is the relation between all the rule base. So here we actually consider that the output membership function and neuron combine all the input by using the fuzzy operation, that is the union. The operation can be implemented by the probabilistic or, that is the x1, mean what is the or rule where you can use, depending on the rule logic is there, you can use the either and or, you can consider and or. So this type of the dependent of the fuzzy set, depending on the fuzzy set, dependent of the use with this. Here we actually use the or. So you can see that the mu R1, you understood this thing. What is actually considered a different rule? We actually put the C1 and C2, and depending on the C1 and C2, you can see the mu R3, mu R6. This is the 2 is coming, and the C2 the mu R1, mu R2, and the mu. So this C1 and C2, this what is the rule? Which rule will fire? That is totally designed to you. Mean the which rules if fire and how actually can clustering the C1 and C2. That is actually totally depend on the design to design. So C1 and C2 when you can design, how you can got the output, that is actually you can consider probabilistic or. So we can actually mu C1 and mu C2. Mu C1 is represent the integrated firing strength of the fuzzy rules, neurons of the R3 and R6. Again, I repeat one by one. First, the X1, we actually fuzzification your total system. After the fuzzification, we actually generate the rule base. That is also you can actually design. So which rule will be fair depending on your system, you can actually design your rule base. After that, the membership output. Sometimes we can consider normalize, or here we actually consider the output membership layer. So you can also your own logic. You can use your membership function. And last layer 5, we actually consider the output. We already discussed the output membership function. And layer 5, we actually consider the defuzzification layer. That is, we actually consider sometimes we consider output layer. So layer 5 is the defuzzification layer. I mean, up to we actually consider the layer 2, layer 3, layer 4. All is the membership function. Now the keys value we designed from the layer 5, because our layer 1 we actually consider the keys input. So after the layer 5, we actually got what is our keys value output in a system. So keys value we actually got for after the defuzzification methods. So the layer 5, we actually consider the defuzzification methods. So in the defuzzification methods, you understood this thing. D5 is the defuzzification layer. So each neuron in this layer represents a single output of the neurophagy system. It takes the output fuzzy set clapped by the respective integrated firing stain and combine them into a single fuzzy set. You understood this thing. So this is after the membership. You can got two value, mu C1 and mu C2. But mu C1 and membership, both are the your membership value. From this membership value, we required a keys value. So we actually, in the layer 5, we actually incorporate the defuzzification layer. In the defuzzification layer, our membership value is actually converted to our keys value. So it takes the output fuzzy set clipped by the respective integrating firing stain and combine them into a single fuzzy set. So neurophagy system can apply the standard defuzzification method. So there is the different defuzzification methods is available in the literature, or we can use the centered method. We can use the min max methods. So here we use the sum product composition method. So sum product composition methods is there. We can use. So this is, you can see that what is the sum product composition method. So we designed by the mu C1 and mu C2. Here the C1 and C2. So we use the after the weighted average of the centered. Means the what is actually you can got the from the mu C1 and mu C2. From that we actually find out the what is the weighted average, and that we actually put into the our formula. So AC1 and BC1 we actually got from the what is actually mu C1, that is actually the combine of the you can see that the mu C1 is the combine of the two rules, that is actually the YR3, YR6, and similarly the you can mu C2, that is the combine of the three rules, mu R1, mu R2, R4 and the R5. So centered up from this we actually got the A1 and the B1. So AC1 and BC1 and NC2 and BC2 we actually got from the centered method, weight average of the centered of the heap fuzzy set C1 and the C2. Now up to that we actually go through the architecture. You understood this thing. We actually discuss about the how we actually use the neural network architecture in the fuzzy system. Up to we actually not go through the any learning algorithm. Now this thing is actually next, our main task is that how we actually can learn to the neurophagy system. Mean the how the neural architecture we actually use the learning algorithm in the system. So neurophagy system is essential in a multi-layer neural, and it can be used apply in any standard. You understood this thing. When we actually use after you can got the Y, mean the your output in your system. If you have the desired output, you can actually use the Y, mean the your desired output minus your actual output. You can actually find out the error. That error you can actually back propagate it, and due to the back propagation algorithm, you can change your instead of the weight matrix here we actually use our rule base. Mean that you can change our the architecture of the your system, mean the architecture of the membership value. So same way, the neurophagy system is essential multi-layered neural network. It can be applied a standard learning algorithm developed for the neural networks, including the back-propagation algorithm. When training the input-output example, now you understood this thing. After you can find out your exact value, means that you can find out your output, your calculated Y, that is actually keys value. If you go through the supervised learning, that is when you can use the backpropagation. So you have the desired value is there. So you can find out the error YT minus Y. That error will be actually backpropagated. The same backpropagation algorithm we can use apply to the neurophagy system. When training input and output example is present into the system, the backpropagation algorithm computed the system output and compare it with the desired output in the training example. You understood this thing? What I say? So you have the computed the system output and compare it with the desired output for the training example. The error will be back propagated propagated backwards to the network from the output layer to the input layer, just like our backwards algorithm. The neuron activation functions. Neuron activation function is modified, the error will be propagated. Neuron activation function is dash one. This one means this triangular function. This propagated function, that will be actually changes. Instead of the weight matrix, we understood this thing here. If this A1, A2, A3, the mu1, A1, mu, if the A and mu is changes, if this system is changes, your mu A1, your membership function is also changes, your output is also affected. So instead of you can change the weight matrix, here we actually consider our membership function, that is the activation function we changes. So when you can go to your learning algorithm, instead of weight matrix, we actually change the neuron activation function and modify as the error is propagated. So when the error is propagated, we actually change our neuron activation function to determine the necessary modification. The backwards algorithm differentiated activation function of the neuron. So in the learning algorithm, when you can apply, instead of we actually consider the weight matrix, we actually change the activation function of the system. Now, what is the summary of the neurophagy system? Before we start the neurophagy system, this is in the neural network architectures. We actually in the neural network, the fuzzy concept we apply into the neural network architecture. So the combination of the fuzzy logics and neural network constitute the powerful means for design an intelligence system. Mean the architecture is neural network, but in the architecture we use the fuzzy concept. Domain knowledge can be put into the neurophagy system by human expert in the form of the linguistic variable and fuzzy rules. You understood this thing? Layer 2, layer 3, and the layer 4. This is depend on the totally your own concept. What do you have the knowledge? What is you can design your rule base, your knowledge. Depending on that, you can actually incorporate your rule base as well as your output membership functions. When representing the set of the example is available, the neurophagy system can automatically transform into the robust set of the fuzzy if-then rules and therefore reduce our dependency of the expert knowledge when building the intelligence system. So if you use your own logics and this system is learned, so both your own logic as well as the learning we can actually incorporate into the neurophagy system. Now, how actually can operate the fuzzy neural network based system? Here we actually consider the conceptually we actually put. Now another architecture we actually discuss here. Sometimes we actually consider the weight. Here up to we actually not go through the weight of the system. Sometimes then in the neural network, the weight we also incorporate. Weight is actually considered as the rule of the system, and that weight will be actually updated. So that we actually consider the fuzzy neural network based system. Now, how actually can implement this system? That is sometimes we can consider the FNN algorithm. First, we actually just like our neural network, we actually selection of the input and the output variable. Now generate the input value and the corresponding desired output value, that training the fuzzy relationship matrix. What is the fuzzy relationship matrix? That is I discuss later. You can understand this thing. First, we actually use the selection of the input and the output variables, and depending on the input output variable, we use the fuzzy relationship matrix. That is I discuss what is the fuzzy relationship matrix. Step 2, determination of the inverse of discourse, means we actually find out what is the maximum input in your system. Depending on the input, we actually consider number of linguistic variable as the input parameter, as well as we actually consider number of linguistic variable into the output parameter in your system. So you can see the understood this thing. If we know that the maximum x means the maximum and minimum value of the input, depending of the input value variable, we actually consider the linguistic variables. We go to the one example. Suppose we can understand this thing. If we know the range, that is you can see the this expression minimum x and maximum x. If you know, depending of that, we actually consider the number of neurons. Mean that here we can actually consider the input nodes. Input nodes means actually in the neural network, how many nodes you can consider in the input nodes. mean the input. After the input, we can consider when you can fuzify number of linguistic variables mean number of node into the your hidden layers. You understood what I say? Mean the how actually fuzzified. Suppose the x is your input. If we use the suppose the three linguistic variables, so second layer, your number of nodes into the your second layer is the number of node, mean the number of fuzzified value. So you understood this thing here. The three nodes we actually consider, three linguistic variable is considered. So the second layer, so we actually consider the three nodes. So you can see that the what is actually the what I say. So suppose the x is your input. This layer, the second layer is the you can consider the number of nodes in the second layer means the number of linguistic variable in your system. Means that here we actually consider the three nodes. You can see that the x1, x1, x2, x3. Here you can see that x1, x2, x3. So that node we actually consider number of linguistic variable in your system. So similarly, the output, when you can consider the output nodes, we also consider the linguistic variable into the system. Number of nodes is actually the output. Mean that initially what is the desired output, that we also fuzzified. That is the another architecture we have discussed. So that is also fuzzified. So between the input output nodes, you can see that your input and your output nodes, the relationship between the input output nodes, we actually consider the initial weight matrix. That weight matrix is actually called the fuzzy relationship matrix. You understood this thing, what I say? So initial the fuzzy relationship matrix, that is actually nothing about this is the relation between the input and output. So what is the input nodes and what is the output node? What is the relation between the input and output? That relationship actually you can represent by your that is actually can consider our fuzzy FNN, that is fuzzy relationship matrix. That is actually represented by the FNN in the W11, W12. So here you can consider that you can see that this is the three inputs, three nodes. Here also three nodes. So the nine logic we actually consider, or nine relationship we actually consider. So initial weight we actually fixed. That is the we actually consider it is the total depend to you. This is actually total to the design means the how actually you can put your rule base, how actually find out the input output relationship. So that input output relationship, just like our previous what is actually our previous knowledge in our rule base arbitrary, what is actually weight matrix we actually choose into the neural letter, same way we actually put our weight matrix, we actually choose the weight matrix into the here. Now our next step, we actually compute the FNN output, that the fuzzy neural network output pattern, that is the y1, y2 up to the yn. Means that here the three input is there. So how actually you can find out? That is the xi, that is your membership function, what is actually considered number of linguistic variables. So this is you understand this thing. When any input is there, corresponding you can go to the membership function. After the membership function and into your fuzzy relationship matrix, so you can got the yj. So that is the three linguistic relation. Yj is actually you can calculate xi into wij. So the pattern of the fuzzy sets of all the linguistic description of the objective y, and wij is the fuzzy relationship degree between the linguistic description of the x and j linguistic description of the y. So you understood this thing. The x and the y, we actually between the x and y, the one fuzzy relationship matrix is there. So what is the y? That is totally depend on your wij as well as the xi. So what is the value actually? How many linguistic variable you want? If you change the linguistic variable, your yj is also changes. If you use the fuzzy relation matrix, you can changes. Your yj is actually the changes. So these two you can actually decide how many linguistic variable you want and what is your fuzzy relationship matrix. The next step, after you can find out your yj, that is your calculated y, your next step is actually your learning the algorithm. So training the networks, that is how you're learning the system. So computing the training errors. So fuzzify the corresponding desired output yd, obtain a fuzzy sets. So that is the yd1, yd2 up to the ydm by means of the fuzzy membership function for yd. So you can see that we actually find out the yd, different of the fuzzy value. Here also we can go the fuzzified value. This is the actual value you can actually calculate from your relationship. Here the actual value we also fuzzified. Then you can comparison these two value, and then you can generate the error. So compare the difference between the yj between the each linguistic variable of the yd and the y. And after that, we actually find out the yjd is minus yj. So you can see that we actually find out the yij equal to xi into wij. So this is actually the compare the difference between the each linguistic variable yd and the y. So we actually find out the difference between the means that we can find out the total error signals. Understood this thing? We actually find out the total error signal in the system. After you can find out the error signal, we actually compute the least square error. So you can actually find out what is the least square error in the system. So that we actually find out from this system. So 0.5 equal to mu j. So this is, you understand this thing? This is the same type we actually use for our neural network. First, we actually find out what is the desired value, your actual value. Then we actually calculated what is the error. From this error, we actually find out the least square error. So if the least square error is within the range, so you can stop. But if the least square error value is more, so we actually upgrade our weight matrix. So we actually go to the step 10. You can understand this thing for weight modification. So if your system is actually your within your error value is more, so we actually go to the weight modification, just like our neural network. So you can see that apply the Woodhope algorithm. Hope algorithm, we can modify the weight. So you can understand this thing, initial weight, and we actually use the weight matrix. How actually can generate? That is we can use the learning rate, moment of coefficient, just like our neural network upgradation of the neural network. Just same type we can actually use here. After we can actually change the weight, so new weight will be actually generate. And again, we actually go to the return to the step 5. Means that again, we actually go to the after the weight, we can changes. After the weight matrix is again we actually generate the because the input x1, x2 is not changes, because the same weight same x we actually consider. We just change this weight matrix. After we can change the weight matrix, again we actually calculate our calculated value. Again, we actually find out what is the error matrix, and in this way we actually find out our 10 weight matrix. So after that, we can actually consider return to step. All the input patterns are checked. If we go to the step 11, means the stop, and then we select the next input and corresponding desired output of the go to step 3. So the first one we actually consider the number of input we can consider. You understood this thing? First, the input is there. From the layer 2, we actually fuzzified the input. Then we actually consider FNN, fuzzy neural network architecture, means that we can actually consider the fuzzy relationship matrix. From the fuzzy relationship matrix, we actually find out what is our calculated output y. From the desired output, we also the fuzzified. From the desired output and your actual output, we can find out what is the error. And for that error, we actually propagated. I understand this thing. This error we actually propagated, and we actually changed our weight matrix. Woodhope algorithm we actually use. So here we actually change our weight matrix. So after that change the weight matrix, fuzzy relationship matrix, we updated. Again, we actually same procedure from the step 5. That is, we actually calculate the output pattern. After the output pattern and your desired pattern, we actually check up to the signal is actually your whole the system will actually go up to the system is actually least square error is less than 10 to the 1. So this is actually depend to the u to u. So after the system is 1 bar. So after that 10, we actually go to the new total 10 FRN matrix, fuzzy relationship matrix. This is the 10 fuzzy relationship matrix. Then you can actually go to the defuzzification. So you understood this thing. Here the little bit difference is there. So after the 10 and your networks, so then we actually consider your defuzzification methods. So x is real value. After the x1, x2, we can fuzzify. 10 the networks, we actually go to the y1 and y2. After that, we actually consider the movement methods. After 10 FRM matrix, after the system is 10, so then we use the differentiation moment methods. So you can use the summation of the real values. Moment methods is there. Centered moment method, moment methods we use. Then we actually got the our desired value. So desired value we actually consider the fj into yj into yj. Yj is actually nothing about the what is the number of linguistic variables you can use, and this is actually you can use the how many functions we actually system. So we actually got the our real keys value in your system. So x is your real input and y is also keys value. Between the input and output, we have the linguistic variable parameters. We have the 10 FRN matrix. We also the output linguistic variable. So this is the total architecture of the fuzzy neural network, FNN system fuzzy neural network. Next or last, we actually consider the last ANFIS. So this is you can see the adaptive neuro fuzzy inference system. So how the system will be more adaptive in the nature. So sometimes we actually consider the ANFIS. We actually consider the use this term is actually ANFIS networks. Now, what is the basic structure of the up to you understand this thing? We use the Mamdani type fuzzy system. The Sejournot fuzzy model is proposed for the generating the fuzzy rules. Means the up to we actually consider the tangular members output is also you can understand in the fuzzy value. But when you consider the single tone, when you can use the single tone fuzzy system, we use the Sejournot fuzzy models. So here we actually use the adaptive fuzzy neural fuzzy system. This is the little bit difference between the previous system. Architecture was same, but the output wise, this is the difference. This is the use the single tone fuzzy system. So you can understand this thing. A typical fuzzy rule expressed in the following form: if the x1 is a1 and x2 is a2 and xm is am, then y is equal to the function of x1 x2. This is the linear relationship x1 x2 up to the xm, where x1 x2 xm is the input variable and a1 a2 and am is the are the fuzzy set. That is the fuzzy set means actually the your fuzzification value. But the architecture, so that we actually discussed. So order of the fuzzy model. So here the y is the constant. That is again I repeat, this is we can consider only a single value, not the fuzzified value. Here output is only a single value, zero order fuzzy model, which consequence of the rule is specified by the single tone. So y is the first order polynomial, that is we can represent by the y is equal to k naught k1 x1 k2 x2 up to by km xm. We obtain the first fuzzy model. So how actually you can use again this is the same structure, but you can see that the your y is actually the single tone fuzzy system. So the layer one same architecture we use here, only the output is all little bit different. Architecture wise this is the same. X1 is the input layer, layer 2 is the fuzzification layer. So the when you can consider the input layer, neurons in this layer simplify pass the external keep signal to the layer 2. So the you understood this thing. Number of, again I repeat, the number of layer 2, number of your fuzzified, number of the your linguistic variable into the your input value is the number of nodes into the layer 2. That thing is you should know. Mean the how many linguistic variable you want. So that we actually put into the your layer 2 neurons nodes. If you use suppose x1, you can actually divide into the 5 linguistic variables. So here layer 2, your linguistic variable a1 to up to the a1 to a5. In this cases, the 2 linguistic variable is there. So we actually consider the 2 nodes e1 and the e2. Similar the input to x2, that is also the depend on the 2 layers. So you can 2 nodes. So you can see that there is the 2 nodes b1 and the b2. So here the number of nodes is also the b1 and the b2. This is this layer 2 is also called the fuzzification layer. We already discussed about the previous cases also. The same thing here also. This is also the fuzzification layer. Previous cases we actually consider the triangular membership function. But when you can use the adaptive ANFIS network, your input, this is the activation function here, the Bell activation function we consider. We define the activation function is there triangular, trapezoidal, G-well shape, Gaussian membership functions. So here the Bell activation function we use for the layer 2 for the activate the your system. Mean that we can actually find out the what is the membership function. That membership function we actually use for the Bell membership function. Layer 3 is actually the rule based. You understand that layer 3 use the rule based in a system. So the here the each neurons, you understand this thing, each neuron in this layer corresponding to the single type fuzzy rules. A rule neuron receives the input from the respective fuzzification neurons and calculate the firing strength of the rule it represents. Again, I repeat, you understood this thing, the rule 3. So rule 3 is actually represented by the design to design. So how you can find out the relation between your x1 and x2, that is actually represented by your rule layer 3. So that you can understand this thing, each neuron on the list layer corresponding to the single serotype fuzzy rules. A rule neuron receives the input from the respective fuzzification neurons and calculate the firing strength the rule it represents. In a ANFIS, the conjunction of the rule attendants are evaluated by the operate product. So same type, you understood this thing. Here the mu A1 is coming, here the mu B1. The output of the layer 3 is actually the mu A1 into mu B2. So the output of the layer we actually use the product operator. So the layer 3 we already discussed. There's a rule layer, and you can see that the ANFIS when you can use the product of the system. So here we actually see that the mu A1 into mu B1, that is the mu 1, that is the output of the layer 3. You can see the output of the layer 3 we how actually calculate, that is the product of the. So the mu A1 represents the firing strength of the truth value of the rule 1. So you understand this thing. So rule what is actually the rule fire? Here the 4 rule we actually designed. So the mu 1, mu 2, and mu 3 and mu 4. So mu 1 is actually the product of the mu A1 into mu B1. Mu 2 is the product of the mu A2 and the mu B2. Similarly, this is the mu A3, mu R3, that is the rule. That is the product of the mu A2 and the mu A1, and the mu the rule 4, that is the product of the mu A1 and the mu B2. So in this way, we actually generate the rule 3 output of the rule 3 value. Now rule 4 is actually the normalized layer. So after we can generate the rule, all the rule will be actually we can normalize. So that rule here, another part, VS cases we actually consider the membership function. Here you can see that we generated the normalized layer. So in the normalized layer, each neuron in this layer receives the input from all the neurons in the rule layer and activates the normalized firing strength of the given layer. So you can see that the N1, N2, N3, N4, we actually find out the normalized layer in a system. So after the normalize the rules, the next rule, normalized rules, how actually you can find out the normalized layer, what I understood this thing. So you can very clearly, you can see that, so the mu A1. So what is the output of the mu N1? This is the Y1. So mu Y1 means that here the rule 1 divided by all the rules. So here the 4 rule is there. So you can see that the mu A1, mu 2, mu 3, and the mu 4. So the normalize all the rules. Similarly, we can find out the output of the mu Yn2. That is the layer 4. That is the you understand that the two thing is there. Superscript actually depend the number of layer. So output of the layer Yn1, similar the Yn2 layer 4 mu 2 divided by the input of the 4, similar the mu 3 and the mu 4. So the after the layer 4 we actually normalize all the input. So layer 4 we actually normalize all the input what is actually coming from the layer 3. After the layer 4, layer 5 is actually the fuzzification. You understood this thing. So this is actually the, we can use the defuzzification layer. Layer 5 we actually consider the defuzzification layer. So you can see that the layer 5 very carefully. Here the x1 and x2 again actually you can consider x1 and x2, and what is the your normalized value, what is your membership value. So that is actually put into the layer 5, and this is the formula we can use for the your defuzzification method. Each neuron in this layer is the connected to the respective normalized neuron, also receive the initial input x1 and x2. A defuzzification neuron calculate the weighted consequence value of the given rules. So that you understood this thing in the x1 5. So what is actually the value is actually coming? Mean the what is the, your output of the your rule 4? Mean the your layer 4. What is the output? That into we actually consider the linearization of ki1 x1 into ki2. That value ki1 i2 you can choose. For the depending of the your linearization, this is the linearized value is actually considered. You can see that the initially we actually consider the output of the this system is equal to k0 q1 is k2 x2. The same formula we actually apply here. Same formula we actually use there. Only we actually find out the layer 4 what is the your membership function, that is actually input multiplication of the system within the x1 and x2. We got a single value in it. So not that this is the fuzzified value. This is the single value we actually calculate from the your systems in the y. So in the defuzzification layer, we use this corresponding this formula, and we actually got the our y out in the system. So xi is the input and y is the output of the defuzzification neuron in the layer 5. When qi0 qi to the set the consequence parameter of the rule I. So after the defuzzification, up to we actually use the fuzzy concept into the neural network architecture. The next part is actually the learning. Now, how we represent into the single simulation neuron? This neuron calculate the sum of the outputs of all the defuzzification neuron and produce the overall ANFIS output into the Y. So if you understand this thing, if the different of the Y1, Y2, Y3, after we can actually calculate the all the output in your system, means the I1 is equal to 1 to n. So here the n is equal to 4. So after the 4 input we can actually consider, because the yi1 you can see that the y1 mu 1 to up to 4. Up to 4 input is actually coming. We actually got the overall output, ANFIS output in your system. After you can find out the ANFIS output, then we actually go to the rule consequence parameter, mean the how actually you can use for the our training purpose. Mean the training, how actually you can train the network. So it is necessary and prior knowledge of the rule consequence parameter, and ANFIS learn this parameter and tune the membership functions. So the how the learning algorithm we use into the your neural network architecture. So in ANFIS use the hybrid neural learning algorithm that combine the least square estimator and the gradient descent methods. So here we use the learning two types of the combined least square estimator as well as the gradient descent methods. In the ANFIS training algorithm, each epoch is composed from the forward path as well as the backward path. In the forward path, a training set of the input patterns and the input vector is represented to the ANFIS, and neuron outputs are calculated on the layer to layer basis, and good consequence parameters are identified. So you can understand this thing. So we actually find out the desired value. After we can actually know that the mu1, mu2, and mu3, we actually go through the desired value of the up to the y to the up to the number of input means the value. So here the four desired four parameter we actually consider number of p. P is actually nothing about the how many input you actually consider. Here the mu1 is actually 4 input we actually mu1. So we actually find out the desired value 1, 2 up to the p is the number of input in your system. Thus given the value of the membership parameter and taking some p input and output pattern. So you understood this thing. Why do we actually calculate into in this way? If the n number of parameter is there, if the p number of parameter is there, so we actually find out the p number of desired value. So every desired value, we actually mean the actual output is also there. So we actually find out the matrix notation. You understand this thing. We actually find the YD is equal to phi desired output vectors. Mu1 up to this is the desired vectors. And then we actually find out the backwards algorithm. So same thing we actually use the backwards algorithm. Rule consequent parameters are established. We compute the actual output parameter Y and determine the error vector Y. You understand this thing? In the least square error, what is actually your desired value? That is actually you can find out what is the YD and Y you already calculate. These two we actually find out the error, and that error we actually back propagated to the whole the system, and that error signal we actually update the your old matrix. So the anti-staining algorithm suggests to the John that is actually we whole the architecture we consider the Jong 1992 they will actually consider the ANFIS network. Attendant parameter and consequent parameters are optimized. In forward path the consequence parameter are adjusted or attendant paths remain fixed. In backward path attendant paths keep in the consequent parameter as keep fixed. Mean the forward path the consequence parameter are adjusted and attendant paths parameter is fixed, while the backward path attendant parameters are tuned and the consequent parameter is kept fixed. In the ANFIS model with the 4 rules, what is the previous architecture? We use the 4 rules. Here is this is the architecture of the 4 rules system. You can see that this system, if the 9 rule, you can see that the 3 parameter, if you consider the number of input, you can see that the same parameter x1 is you can consider only the 2 input. So the 4 rule is actually generated. If we use the number of layer 2, number of linguistic variable is the 3. So the 9 rule is the generate. So model of the system is if the number of rule linguistic variable you can increase, number of rule is also increase, the complexity of the system is also increasing in the nature. So this is the you can see the you can number of you can 3 linguistic variable you use. So 9 rule will be generated. So the how actually get train the network. So this is the last slide we actually consider. So you can see that the initial and the final initial value of the membership function in a system. So this is the x1, x2. After the upgradation of the system, you can this is the Bell membership function. What I actually consider previous cases triangular membership function. Similarly, here we use the Bell membership function. After train the networks, so you can see that the our membership, the architecture of the membership function is actually the changes. But training actually there nothing actually they will do. Then training after the ANFIS when you can use, they will change the structure of the your membership function. This is actually structure of the your membership function after the epoch 100 epochs of the training. So after the train the network, our system will be the changes. So when we actually use the neurophagy system, the neurophagy system, you use the neural network, the weight matrix is changes. When you can consider the neurophagy system, our activation function, the structure of the activation function is changed by through the in the training. Okay, thank you.
So participants, so you may interact with the sir. If some question, you may ask. Please welcome. If any question, you may ask from sir.
Hello, sir. Hello, sir.
Thank you.
Sir, I have a question, sir. Can we use, sir, RBF function to analyze?
You can also use this system. Actually, we use the neural in the architecture. We use your fuzzy concept. Okay.
Okay, sir.
So if you know the architecture, you can easily use to your fuzzy concept into that particular neural architecture.
Okay, sir. Thank you, sir.
Is there any more? Anyone? Okay. So no question from any participant? Okay, so thank you. So we are going to conclude this session. Thank you so much, Professor Kalyan Chatterjee, sir, for your valuable time and sharing your limpid knowledge with us. Your expert talk has provided us with invaluable insight about intelligent system and its short. Okay, yes. Yes, you explain about soft computing and its advantage, as you also vividly explain the uh, concept of fuzzy number, fuzzy description, fuzzy membership, fuzzy logic based system, and fuzzy configuration of fuzzy logic system. Your illustration explanation of hybrid system, neural expert system, and different layers in neuro fuzzy system was exemplary. You taught us how neurofuzzy system learn and short steps to implement an algorithm, and also explain about adaptive neurofuzzy inference system. I am sure our participants have attained a better understanding about all these topics. Thank you again, sir, for taking out your valuable time to impart us with your knowledge. Thank you, sir.
Thank
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
So, okay, we will meet by tomorrow. Thank you, everyone. You all may leave it.